Concepts and theory of DHCP. DHCP stands for the Dynamic Host Configuration Protocol, and it's a process by which we have a database of IP addresses and IP configuration information that we dynamically allocate to clients as they initialize on our network. So the client comes up, has no IP configuration, sends out a DHCP broadcast because they are enabled for DHCP. That DHCP broadcast is caught by the DHCP server. DHCP server issues an IP address. So that's the basic premise of the DHCP service. Let's go through some more detailed information and specifically how to implement DHCP on the network. Okay, the first thing that we need to talk about is the difference between a static and a dynamic address. Every host on a TCP/IP network requires an IP address. Okay, you can statically configure these IP addresses. You can give everyone a specific exact IP address and then just keep a spreadsheet or a database of all the addresses that you've given out. But that ends up being a royal pain in the neck. Because if you want to change any configuration information, if you're sitting down at a client, you need to give them a new IP address as maybe a troubleshooting method, it's just a pain in the neck. You have to go back to that original database, that spreadsheet program, make sure that you've made that change in the spreadsheet. You have to manually keep on top of this process. What you end up with is errors. You end up with IP conflicts, two people having the same IP address, and so one or the other or both are unable to communicate. You end up with just a big administrative headache. Because humans are humans, we tend to, eventually make a mistake with some kind of manual process like that. Now with DHCP, on the other hand, by allocating IP addresses dynamically from one central source, from one database that we put all of our configuration information into, all the IP addresses that we're going to give out, by doing it from there, we can make sure that once we give out that IP address, we mark it as, given out. So we don't have to worry about that IP address being issued to another client. So we won't have any duplicates on the network. We never have to actually manually manage the process. We don't have to go to a client and change their IP address. They just will automatically get an IP address as they come up, as they turn the computer off, or as their lease period expires, they get another IP address. So it makes for a real easy to administer, easy to manage process. Dynamic addresses really were a godsend. They're an awesome way to manage and administer your TCP/IP environment. Okay, let's talk terminology. DHCP server. DHCP server is a Windows NT server with a static IP address that has the Microsoft DHCP service loaded. The DHCP server is what gives out the IP addresses. On that DHCP server, we have what's called a scope. A scope is the database of addresses from which we draw to give out this IP configuration to the clients. A DHCP client is any client that is enabled for DHCP that will, when they initialize, send out a DHCP broadcast and get an IP address from the DHCP server. A static client, a client with a static IP address, so independent of the whole DHCP process. On the DHCP server itself, when you're creating the scope, you're going to set an exclusion range. The exclusion range will say, these are my static clients. These are the ones that I don't want to give an IP address out to, and by the way, we're going to reserve these addresses. Make sure that we don't give those out because they're already in use somewhere on our network. And then finally, bootp. Bootp is the protocol that is implemented within the DHCP service. So anytime you see a bootp-enabled device, in this case a printer, that can also be a DHCP client. That can get an IP address from the DHCP server. Let's talk lease acquisition process. As a client that is enabled for DHCP initializes, comes on, it has just enough TCP/IP to be able to send out a DHCP broadcast. That DHCP broadcast is felt everywhere on the network segment where that client exists. So if there's a DHCP server on that segment, the DHCP server will say, hey, I can help you out with that IP address, offers an IP address to the client. The client takes that offer and says, yes, I agree to using that IP address. The server says, okay, you're confirmed. Kind of like when a a network consultant goes to get a job. Ask for the job. The server says, yes, I have a job here that I think you would be great for. Do you want it? The client says, yeah, I want it. The server says, you're confirmed. You're hired. Okay, so lease acquisition process. The lease renewal process is as follows. Let's say we have a DHCP lease of 3 days, which means that I own that IP address for 3 days. Well, at 50% of my lease interval, so at a day and a half, I'm going to send out a renewal request to my DHCP server. So if the DHCP server's up, he's going to say, all right, you've got it for another lease period, so for another 3 days. So as long as both machines are up, you'll theoretically keep that IP address forever. Now your lease is also going to be renewed whenever you turn the computer off. So turn the computer off, turn it back on. As you initialize, you're going to renew that same address. You're always going to attempt to get the same address that you had the last time you were up. Now if that address was since given to someone else, you'll just get a different IP address. As well, after that 50% of the lease renewal, you go through half of the lease, attempt to renew. If the DHCP server is not up at that point, you'll still attempt to renew at certain intervals between that halfway point and the end of your lease. If the DHCP server is down through the end of your lease, you release your IP address, you have no IP configuration, and you stop being a client on that TCP/IP network. So we talked about a scope being the database of addresses that we're going to give out our IP from, give out our IP configuration from this database. Well, the database is just addresses. We also want to give out the address of the WIN server, the address of the DNS server, the address of the default gateway. Because your IP configuration is not just an address and a subnet mask. You also need DNS for that hostname resolution, WINs for the NetBIOS resolution, default gateway to get off of your local segment. So what we do is we set up what's called a DHCP option. A DHCP option is that additional parameter that goes with just the IP address. So we're going to set 4 DHCP options. One for the default gateway, one for the DNS server, one for the WIN server, and then whenever you set a WIN server address, you also have to specify what type of a NetBIOS resolution client will that WIN's client be. And so that's called the WIN's node type. So those are the 4 options that we'll set up. Now you can set up either a global or a scope option. A global option applies to all scopes on the computer. A scope option just applies to the scope. Now what you do is you create one scope for every network segment that you're supporting, that you're giving out IP addresses for. This DHCP server is on this network segment, so it's going to create one scope for this network segment. It's also going to create a scope for this network segment, this network segment, this network segment, this network segment. So we've got 1, 2, 3, 4, 5 different scopes that we're going to create. Now we've got one WIN server, and it exists right here. We've got one DNS server, and it exists right here. But every single network segment has their own default gateway. Default gateway for this network segment, default gateway for this network segment, default gateway, default gateway, default gateway. So you can kind of see what should be a global option, what should be a scope option. Remember, each network segment has its own scope. Each scope has its own default gateway, yet there's only one WINs and one DNS server. So you see that the DNS and the WINs address, they will both be global options. And the default gateway, that will be a scope option.